And I'll repeat that. Okay, so sensation is um, the process by which all the sensors all over our body, in our ear, in our nose, in our eyes, and, all over our skin, and, the vestibular system in our inner ear to know where we are in space, takes in information from the outside world and then translates it into information that the brain can understand. So it translates it into neural impulses, kind of, like action potentials that get sent all the way to the brain from wherever that information is coming from, the tip of your big toe, the tips of your fingers, wherever, to the part of the brain that processes that information. And it's different from perception because the perception is how our particular, personal individual brains um, interpret that information. So we all have, you know, given that we all have, working eyes and working, sensory perceptors on our skin, we're getting the same physical information from the environment, but we might be interpreting it differently, right? So one example I always like to give is um, this. Where is it? It's not in my- Let me close this. See if I can share it again. Or maybe I'll just share the desktop and it'll let me. Can you see the dress? Okay, so you remember this dress? And so what's the deal with this dress? Can somebody tell me?
People see the dress is different in a different color.
Right. So can somebody tell me what colors they see?
White and gold.
Mhm.
Black and blue.
Does anybody see a different color?
I see blue and gold.
Blue and gold, okay.
I say blue and black.
Blue and black. Okay, so raise your hand if you see it as yellow and bluish white or white. 1, 2, 3, 4, 5, 6, 7, 8. I don't know. Sometimes you appear on both screens. Maybe 9, 10. I'm not sure. Okay, now raise your hand if you see blue and black. 5, 6, 7, 8, 9, 10, 11, 12, 13. Wow, more people see it as blue and black. I see it as like gold and white. And does anybody know what color the dress really is in real life?
The lady said it was, isn't it blue and black?
Yeah, it's blue and black, and I was like outraged. Anybody else outraged that sees it as yellow and white? And that's because of how we perceive things differently. There's also things like, what we've been primed to see, what we've seen more of in our lives, but also, the noise in the environment, like what's nearby it that changes how we see the color of it. How things look like different colors depending on how much light there is in the ambient environment. But we'll talk more about that when we talk about perception. But so the sensation is we all are seeing the same picture. The same light waves are, bouncing off the screen and getting sent through the little holes in our eyes, the pupils, to the back of our eyes, the retina, where we have photoreceptors, rods and cones, that transduce that information into an electrical impulse. And that gets sent down the axons of the optic nerve to our brain through the thalamus and to the occipital lobe in the back of our brain. We all have that process, assuming that we all have that none of us have a big visual impairment. Okay, or, you know, we might have different cornea shapes and different shapes of our sclera that change how well we see it. But the physical characteristics of the light waves are the same for all of us. I mean, we might have different computer monitors, but basically those physical characteristics of the light waves are the same. That sensation, right? And then the perception is which we see, what we see based on who we are. Right? Can you guys think of any other little common perceptual things like this that have been in the popular media lately? They could be other senses too.
I think there was one that went around with what did you hear? I don't remember what it was.
What did you hear? Yeah,
But-
Laurel or Yanni.
Yeah, there's that
Remember?
one.
Yeah, do you want to listen to that one? Let's see. And, you know, so it does affect everything, right? I mean, and it also depends on which one you download, right? Some of them are more difficult to perceive than others, but you know, we'll just try the first
The
one we
average person
see.
has over 100
Or
online
here.
accounts scattered across the internet. But with Allstate's new digital footprint, you can control all your data.
I don't like making you guys listen to ads.
Laurel, 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 Laurel.
Okay, who hears what? Who hears Yanni? And who hears Laurel? It's so wild because I don't hear Laurel at all. I love it when other people, I love when people hear the one I don't or see the one I don't. I don't know why. It just blows my mind. And then there are some that, have you seen the ones that are like, whichever one you read at the same time is the one that you hear? It's like thunderstorms versus something else. I can't remember. I'll try to find it.
Brainstorm,
Brainstorming.
like a brainstorm, and then like there was one that was like green needle and something else.
Oh yeah, Gray Needle and Brainstorm or something. I love that one. And I think, I don't know, my experience has been that that young people disagree with my perception more than people my age. So I don't know if it's because like our sensory receptors are like fading or something. I'm not sure. That'd be an interesting study, and I'm sure they've done those studies. Okay, so let's do a new share. Oh, you can just do a new share now. It's exciting. Do you see, what do you see right now? Do you see Yanni still or the PowerPoint?
Both.
Okay. I'm gonna have to stop sharing and start again. Now it's just the PowerPoint? Okay. All right, so that's the difference between sensation and perception. Hopefully that makes sense to you. So sensory information, you know, it includes the five senses, obviously, you know, and what are the five senses? Well, they're right there. But there are other ones too that you don't obviously think of, like kinesthetics, like where you are in space and how you're moving through space. And, you know, some people are like gifted in that and know exactly where they are, you know, and exactly how to anticipate where other people are moving. And some people, you know, don't have the same ability, but, you know, we're getting the same information from the world, right? I mean, we've all got the same gravity affecting us all, right? Anyway, so things like pain and temperature, those are due to different, specific receptors for that on your skin. And some people have you heard of the disorder where people don't have those receptors? So some people, yeah, so some people have a disorder by which they can't experience pain, from, an injury from outside. And you might be like, oh, great, that'd be great. But little kids, don't know to remove their skin from something that's burning them. They don't know if they're rubbing up against something sharp. So they're really exposed to and vulnerable to severe injury. So it's not a great thing to have. And the people who have it have to like really protect themselves. And they wear protective clothing and, they have to learn to be vigilant. Can somebody tell me what an absolute threshold is? And this applies to any sense. What is an absolute threshold? And by the way, I won't know if you have your text open in another window, so you can kind of, cheat. I wouldn't consider it cheating, if you don't remember exactly what you read. I had to read
Well,
it.
according with the book, is a small level of stimulus.
Yeah, the minimum stimulus needed to detect something. And it's actually half the time, but your book doesn't talk about that, so we're just going to blow that off. But it's the lowest intensity of something that can be detected, right? So let's see. When you have to get up and go to the bathroom in the middle of the night. So it's like the lowest level of light you can use to see where you're going when you try to get to the bathroom without killing yourself in the middle of the night, so the minimum, or maybe like the faintest light you can detect on a radar screen, right? Or say you're looking out into the fog trying to see a building or something on the horizon, and when you can first see it, that's the minimum, that's the absolute threshold. And it changes obviously based on the level of what's called noise in the environment, but noise isn't always auditory, it's not always something you hear, right? So whether you can see something might depend on what else is around, right? Like if I turned on my phone's flashlight, if I like put it on over here, you probably wouldn't detect it. You wouldn't know I turned it on, right? But if I pulled down all the shades in this room and turned off all the lights and then put on my phone's flashlight, you would probably see a beam of light coming from my phone, right? So do you get what I'm saying? Anybody? Yeah. So the absolute threshold will change sometimes based on what else is around. But when people who are studying this are trying to figure out what the average human being's absolute threshold is for a sound, they try to like control for all noise, so they try to kind of do it in a vacuum, if you will. So they like filter out all the other noises and put headphones on you, right? So when they do a hearing test, you've all had hearing tests, right? You all should have during physicals and stuff. And in most of the public schools, they do them. So they put headphones on you and they play tones, right? And you're supposed to say, what side you hear it on, or like indicate when you first hear it, right? Well, they played some tones that you didn't hear. You didn't hear every single tone they played, right? And because there are some tones that are outside of most people's human, ability to hear. They're a different frequency. They're a different sound wave than humans hear, right? And we know that other beings have different abilities to hear than we do. right? They can hear other frequencies that we can't. Can someone give me an example? Oh, here's my cat.
Would an example be a dog whistle?
Yeah, like a dog whistle, we can't hear it, right? But if you train your dog to come running when they hear the dog whistle, that's evidence that they can hear it, but we can't. I have like a little cat trainer thing that when my cats are like jumping on my face in the morning at like 3:30, I can press this thing and I can't hear it. And the cats are like, "Ugh," and they get away from me, right? And then there's one that I press when they're doing adorable things. There's 2 buttons, positive and negative. And the positive one I can hear, and it's a noise that they kind of know that they're doing something I like when I play that noise, right? Trying to think of other things. I remember when I went to grad school in upstate New York. And so a lot of this drive is like 4 hours on like a 2-lane highway with woods on either side, right, in upstate New York. So I saw a lot of deer, right? So I like kind of lived in fear of hitting deer. Some of my friends did when they were driving around up there. So I have these things that you stick on your bumpers. And when the wind goes through them, it plays a sound that's very audible. It's like a horn to the deer, but I can't hear them, right? So other animals have different sensory abilities than we do. Actually, we're having, did anybody notice I put a guest in for like March 5th, I think? I don't know if that showed up as a message for you guys, but I have somebody coming in who I went to high school with her. She trains her dog to detect drugs. And his name's Zargo. He's a black German Shepherd. And she does it mainly because he's a rescue that has horrible behavioral issues. He's really aggressive towards other dogs. And she couldn't take him out on trails and hiking and stuff. So she had to like give him something to do so that his life wouldn't be miserable. And so she does these dog training things with him. She goes to groups where people learn how to do it. And I looked it up. I forgot the numbers, but dogs have, let me look it up really quick. Dogs have like hundreds of thousands more olfactory receptors than we do, right? You ever like take your dog for a walk and your dog's like, and like has to go towards something? People who have dogs and you have no idea what it is, right? And you're like, oh, you smell something good, huh? Right? And they can smell stuff that we can't, and that's, you see those dogs reuniting with their owners like 17 years later, and they obviously recognize them. A lot of that is scent, because they have just such different and so much better smell receptors than we do. Okay. Oh, all 3 cats are here. I have to get like a separate camera so I can have like a cat cam. They're fun. Okay. So messages that are below the threshold for minimum detection are subliminal messages, right? So if something's below the absolute threshold, but you can detect it like some of the time, that's a subliminal message. So if someone were to, play you an advertisement for something and then pipe in the word sex, like just low enough that you only heard it like a quarter of the time, that would be a subliminal message. And there's evidence that we do perceive things that we don't consciously know we got the physical message for. Like there's a Stroop task. I'll explain a Stroop task some other day. But they put people in an MRI machine that like takes visual images of your brain sliced this way. They don't actually slice your brain, it's images of it if it were sliced this way and then vertically. And it's what's called a functional MRI. They can see what parts of your brain are working when you're doing a particular thing, right? And so they show somebody a clip of a person who just looks neutral. It just looks totally neutral. And then there's like, you know, a fraction of a second where that person looks angry or afraid. Right? And when you take that person out of the MRI machine and you say, what did you see? They say, a neutral looking person. And you say, oh, that was it. There was no emotion on that person's face. And they say, no, absolutely not. But if you look at their MRI, guess what part of the brain looked like it had activity during the part of the clip when the person on the film showed fear or anger. Knowing what you do about the brain.
Is it the frontal lobe?
It could be, but it's the part of the limbic system that's particularly for processing fear and anger. Does
Oh,
anybody remember?
the amygdala.
Yeah. Yeah, the amygdala. So that part of the brain is, you know, shows that there's energy going on there. There's synapses during that part of the clip, even though the person isn't consciously aware that they even saw that. Isn't that kind of wild? So like your brain is responding things that you don't know you're seeing. So if we asked you, did you consciously see this thing? You would say no, but your brain imaging would tell us that you did. Isn't that freaky? I find that freaky. I don't know, I'm obviously a psychology geek though, but I find that wild. Okay, so that's a subliminal message and people have tried to use it to advertise things and you know, people always use those Disney movie weird things as examples of subliminal messages. Those are things that, you know, like does somebody want to give me an example of a weird thing in a Disney movie that you might not notice?
The only thing I remember was, and like there was an original, like I forget, there was a Disney movie and it was like a mouse. It was like about mouses. I'm not 100% sure.
Uh-huh.
The original like cut had like a literally like a 0.5 or something. It was like a split second, like there was like a sex scene in it. Like
Yeah, yeah. And I
like,
think in Aladdin, does anybody know the Aladdin one? I mean, it's a little, I don't
I
know.
know a Toy Story one.
Oh, what's that?
So I think it was like either in like the third one or like the fourth one, but in
Uh-huh.
the background, she like the little girl that Andy gave the toys to, she had a Mickey and Minnie in the background.
Oh, okay. And that's not everybody would notice that. There's one in Aladdin where they're getting married and either the king or the person marrying them has a big noticeable erection. So, but people don't see it, you know, but they're not trying to send a message to people to like buy something or do a particular thing. So it's not like a manipulative subliminal message. It's just the cartoonists trying to be funny and sneak something in. You know, it's not like advertising used to be where, you know, they used to advertise cigarettes in magazines, or maybe they still do, you know, like the actual print magazines, not online. And the smoke spelled out sex, you know, but you had to really look for it. You know, but they thought, oh, well, if we send a subliminal message that makes people associate our cigarettes with sex, people will buy more of them. That kind of thing. Okay. And then does somebody want to tell me the difference threshold? What's the difference threshold?
It's where difference in like the stimulus that's perceived.
Yeah, it's the minimum difference that can be detected, right? So did you ever have, you know, a boomer tell you to lower your music and you lower it and they're like, I said to lower it. And you're like, I did lower my music, right? Or even if, you know, they can hear it through your headphones. And they're like, turn that down. I can hear it through your headphones. And you do, and they think you didn't. It's because you didn't hit the just noticeable difference for them. You know, their just noticeable difference might take a little bit more of a change than yours because you have better hearing than old people, right? Because if they're auditory nerve, like I'm not old, so I'll describe them as they, their auditory nerves are not as strong, are not as well functioning as yours. Everybody loses cilia in their cochlea and get some nerve damage as they age. So, but anyway, other just noticeable differences. Do you ever like smell your clothes to see if you can smell BO on them? And then, you know, you're like, wait, you know, does this smell? And, you know, if you wore it another day or like another couple hours and it did smell a couple hours later and you could just pick it up, that would be a just noticeable difference, right? Or if you touch your radiator and you can't tell it's on, you're wondering if your heat is on. You can't tell it's on, and then, you know, a few minutes later you feel the warmth. That would be, you know, the minimum change in temperature of your radiator that you could tell would be the just noticeable difference. Because the difference, sorry, just noticeable difference is a synonym for the difference threshold, or sometimes they call it the sensory differential threshold. Okay. All right. So again, perception is how we interpret it and consciously experience it. Okay. So sensation is physical, whereas perception is psychological. And attention and motivation determine what's sensed versus what is perceived. I think I have an example on my phone. Let me just see. I don't know if I put it on my messages or what. Just want to see if I can quickly find it. Well, have you seen those videos of someone saying, okay, say these names, and somebody says a certain name over and over again, then you ask them to read something really simple and they read it wrong? That's priming. Let me see if I have it on favorites. Because I know I put it somewhere so I could play it for you guys. Well, I'll play it next time. But anyway, the other thing is sensory adaptation, and that applies to every sense as well. So sensory adaptation is after you've been in the presence for something for a little while, you can't even tell it's there anymore. Okay, bless you. So for example, do you ever go in somebody's room and you're like, this doesn't smell that good? And then you're there for a while and you don't even notice the smell after a while? Or have you ever had that happen to you, that you put on like cologne or perfume or something and you're like, I can't smell it anymore, and you put on more, and then somebody else is like, whoa, tone it down on the perfume? It's because you adapt to it and you don't notice it anymore. So you have to be careful, like not to load it on because you adapt to it, but other people can still smell it strongly. Do you ever have someone else smell your clothes for you to make sure they don't smell bad? Why is that? Why is that kind of necessary?
Because you adapt to your own smell.
Yes, you adapt to your own fragrance, right? So you can't smell yourself anymore because you're with yourself a lot of the time, hopefully all the time, right? So if, you might smell and not know it. So, people ask each other because of sensory adaptation. Did you ever get like a new ring or a new watch and it drove you crazy for a little while? Like the feeling of it on your hand or your wrist was kind of like distracting. And then after a little while, you don't even notice it anymore. Or maybe you got a piercing and it drove you nuts in the beginning. And then you're like, oh, I'm fine. It doesn't even, I don't even notice it anymore, right? That's sensory adaptation. And it happens visually too. If you've ever looked at somebody's eyes really closely, even while they think they're looking out at the same thing, they're just staring at one thing. People's eyes are constantly moving around. People's eyes don't stay perfectly still, right? Because if they did, their eyes would adapt to what they were seeing and they'd have blind spots. So our eyes jump around all the time so that we don't have blind spots. And that's why it's so hard to, like, if I put a bunch of dots on the screen, small ones in a line, it would be hard to count them because it's really hard to keep your place when you're looking at small things. And that's because your eyes are jumping around all the time. They've actually done a study, which doesn't seem really comfortable to me, but they put a contact lens on people's eyes and the person's lying down and there's a tiny, like, almost like a scope attached to the contact lens. Okay, and it has an image in it. So what that does is as the person's eye moves, so does the image. Okay, so that the eye jumping around doesn't help them with the sensory adaptation. So there's an image of like a car that they can see, but as their eye moves, so does the car. So they can't keep their vision moving, so they adapt to the object that they're seeing, a car, and parts of the car disappear because your vision will adapt to that. Okay, so that's why our eyes are constantly moving. Right now, if they're moving a ton, like nystagmus, that people who have vertigo and get it really bad, and their eyes are moving like this after they move, that's something different. Okay, but it's just like the little jerking around that everybody has. Okay, so here's a little cross section of the eye. So like if you slice, gross, but if you sliced it in half, if this person's looking this way and if you slice their eye like that. Okay, so here's the cornea. So the cornea is, a protective layer over your, pupil and iris and everything. I think the sclera, the white part of your eye, is actually the cornea is included as it's considered part of the sclera, the white part of your eye. Okay, but obviously the cornea is clear. And has anybody had LASIK in here? LASIK eye surgery? Yeah, so when they do that, they put laser incisions in the cornea to change the shape of it. So when the light waves travel through the eye, the angle of the light waves gets changed. So it gets projected on the right part of the retina now so that you can see right. Because when you're nearsighted or farsighted, the whole shape of your eye might be affected, your cornea might be the wrong shape. And then things get projected too far in front of or too far behind where the receptors are on the back of your eye. So when they do LASIK surgery, they use a laser to put tiny incisions in your cornea, and it changes where those light waves intersect so that they're perfectly focused right on the retina, which is what people who have 20/20 vision have. Right. Yeah. Anyway, and then the iris is the colored part of your eye, and it's actually muscly tissue. And that's why it looks kind of wavy. You know, it looks kind of like little strands. You know, it's muscular and it's like an aperture on a camera. Like it gets smaller and bigger depending on how much light it needs to let in so that you can see. Right. So it gets big, it lets more light in if you're in a low light situation and less light in if you're like staring at the sun. Bad idea, but you know, some people do that. Anyway, so that's what, you know, that's what the iris is for. And, you know, how much pigmentation is in there determines your eye color. And then the pupil is just nothing. There's nothing there. It's just a hole. And it's, you know, the light waves enter through there. But behind the pupil is a lens. And people get the cornea and the lens mixed up all the time, right? But when people get cataract surgery, they sometimes have this whole lens replaced. And when they get that whole lens replaced, they end up with perfect vision afterwards. Oops. And so the light waves come through the pupil, they get changed by the lens. The lens is what focuses, right? And you guys can, a lot of you can like read, look right up, see the TV, look out your window and see far away, right? When you get older, this lens gets more like stiff and brittle. And so you might have noticed that your parents kind of, oops, I have to turn off my notifications. I have to do that. You may have noticed that some of your parents, like when they look up from reading, they can't see anything. You guys know, like they're like in a fog when they look up from their reading. Has anybody noticed that? That's because their lenses are kind of stiff and old and not working that well. Okay. And then the very center part of the retina is the fovea, and that's where we see the absolute best. Okay. So this is where, you know, we have rods and cones all along our retina, and those are the photoreceptors. And can someone tell me what cones are better at versus rods? What are rods good for and what are cones good for?
Cones are good for seeing color and rods are good for seeing in like black and white.
Yes, good. So cones are for color and detail, and rods are for low light situations. And they actually look like cones and rods, but they kind of came up with this theory before they knew what they looked like. I don't understand how these things happen, but you know, when they do like, you know, really strong magnification of rods and cones, they actually, cones look like little Dairy Queen soft serve ice cream cones, and the rods look like little perfect rods. And I always think, I remember them because the rods look like Maglite flashlights. And they're for low light situations like flashlights are. And cones are for color. That's good alliteration, right? They're for detail too. And, you know, if you had to guess, would you say, how would you guess the numbers of rods and cones would differ between us and cats? knowing what we know about, what most people know about cats and knowing what we know about rods and cones, what might they have more or less of than us?
Do you have more roads than cones?
Yeah, they have more rods than cones and they have way more rods than we do, and because they're nocturnal. So, they need more sensory receptors for low light situations. Another cool thing I found out about differences in eyes between people and animals and among different animals is the shape of the pupil changes depending on whether an animal is a predator or prey. Have you guys heard about that? So what does anybody know, like what shape a goat's pupils are? They're shaped kind of horizontally. It's the weirdest thing. They're kind of like, and when an animal has a pupil shaped like that, it usually means that they're prey. And why would that be? Why would they have a pupil that's like kind of long?
Because they need a better like side vision to.
Yeah, they need better peripheral vision to know if like something that wants to eat them is creeping up behind them. And then things like, cats and tigers have those. That's why they have those little slit eyes. It's because they need laser focus on the thing they're hunting so that they don't lose it in the landscape. Right? Because what goes through that pupil is what hits the retina. And that's what you see the best, what hits the center of that retina, which is the fovea. Okay. We have a blind spot. And it's where, how like when you're driving in a car, there's a place where where your rear window and your back window meet, where there's metal, and that's your blind spot. You can't see if someone's coming up behind you right there. Right? Well, we have a place where our retinas don't have any rods and cones. And it's because all these axons from these rods and cones, or from bipolar cells and stuff that are in the back of your eye, they kind of entwine together and leave your eye. It's kind of like the telephone wire from the back of your eye to your brain. And it has to leave your eye somewhere physically. And where it leaves your eye, like right here, there are no rods and cones. So if some light comes in right here and hits right there, you can't see it because there's no receptors right there. Right? So like if you stare at something that's on one side of a page and you cover your eye and stare at it, it'll disappear because eventually it'll be in that blind spot. All right. So photoreceptors in the fovea detect light. Here are the rods and cones. They actually go to bipolar cells and then ganglion cells. And you remember axons, right? Where neural impulses travel down this long thing to the next cell, right? Not dendrites, but axons. Remember that? The axons of these ganglion cells are what forms the optic nerve. And they all intertwine together and make this cable that leaves your eye and goes to your brain. It's kind of amazing. And by the way, they've been able to mimic receptors in people who have retinas that don't work. And they slide these little chips, they look like tiny, tiny sequins, and they slide them into people's retinas to take the place of rods and cones so that blind people can see, or almost blind people can see. Because if they just don't have, if it's that they're just lacking rods and cones, but their ganglion cells work, you can put something else to receive those light signals. I think that's crazy, but so the optic nerve leaves the back of the eye, crosses over, goes through the thalamus, and goes to the occipital lobe in the brain. And that's where we kind of process it. There are really particular parts of the brain that see specific things. There are this part, so this is where somebody's eyes would be. This looks like two people kind of facing each other, right? And this person's eyes would be here and this person's eyes would be here. There are very specific parts of the brain that are made to see certain things. Okay, there's like a place here that's for houses. And there's a place here that's for faces. And if a person has damage right here, they can have what's called prosopagnosia, or they might just be born with a birth defect where this part of that occipital lobe is not fully formed or damaged. And people who have prosopagnosia can't recognize faces. So people who have that don't recognize their mother's face. They don't have the neural ability to do that. And so what they do is they rely on things like voice, a particular piece of jewelry, or something that that person always wears. They can't rely on face. So this pathway tends to be what people see, you know, on the bottom of the occipital lobe, and then on the back of the head determines people's ability to see where it is in space. Right? So people who damage this part of the occipital lobe might be able to see a house, but they don't know what side of the street it's on. Right? And then people who damage the lower part won't be able to see certain things or tell what it is. Let's see. No, I didn't get to show this video, but I'll show it next time. So maybe we'll stop there. And I will see you guys on Wednesday, okay? Thank you.
Ew.
Bye.
Yeah.
Thanks. Bye.